In this series of lessons we're going to look at quadratic functions. Now a quadratic function is just a polynomial of degree 2. We've seen a lot of quadratic function work in Intermediate 2 or National 5. We've got a very distinctive shape when you sketch a quadratic. It's called a parabola. You can see some in the title menu here. One over here and one over here. Also, when you throw an object up into the air with a slightly forward motion, it will create a parabola. In this picture here we've got a golf ball going up into the air and peaking and then coming back down, due to the influence of gravity. A parabola is always symmetrical as well. It has a maximum turning point as seen here, or a minimum turning point here. Now it always takes this form, ax squared plus bx plus c, where a, b and c are variables. B can be 0 and so can c, but a cannot. If a is 0, then it's no longer a quadratic because you don't have this x squared term. A bigger than 0 or positive gives you a minimum turning point, and a less than 0 gives a maximum turning point. The roots of a quadratic are the points where the quadratic cuts the x-axis. This are the roots here. This is one's got 2, and the roots here are there and there. There's several ways to find them. You can use factorisation, which we've seen before. You can use completing the square, and you can use the quadratic formula also to calculate roots. This would be in the case of when it didn't factorise. First lesson we're going to look at really is how to sketch the graph. Now we could do a table of values, but we're not going to do that here. We're going to use a more mathematical approach by using algebra. So main things we're looking for here is the y-intercept and where it cuts the axis, the x-axis. So the parabola cuts the y-intercept when x is 0, therefore y is 5. If you look at this here, if we put 0 in here and 0 in there, we get 0 squared plus 4 times 0, take away 5. So at x is 0, y is minus 5. That's your intercept. To find the roots, this happens when y is 0, it cuts the x-axis when the y value is 0. So let this equal 0 and then you factorise. You need a plus 5x and a minus x to get your 4x here. 5 times minus 1 is negative 5. So to solve this, either this bracket's equal to 0, in which case x would be minus 5, or this bracket's equal to 0, in that case 1. So minus 5 or 1 are your roots. Turning point. This would be this point here, or in this picture that point there. So how do we find the turning point? Well, if you think of the roots being negative 5 and 1, again I suppose if you look at this here, the turning point's x value is halfway between these two bits. Same over here, you've got your x value of your root and your x value of your root. The x value of the turning point is the halfway line, or the axis of symmetry. So to get the midpoint of these two, you add them together and divide them by 2. So negative 5 plus 1 is negative 4, divided by 2, and you get minus 2. And to get the y value, you just sub it back into the equation. So sub minus 2 back into your original equation, minus 2 squared plus 4 times minus 2 minus 5, and that gives you your y value. So we'll do that here. That comes out to be minus 9. Negative 2 squared is 4. This is going to be negative 8, so 4. Take away 8, take away 5 gives you negative 9. Minimum turning point at negative 2, negative 9. And then we can sketch it. So you show your roots at negative 5 and your 1. Your y-intercept at 0, minus 5. Your axis of symmetry at minus 2. And your turning point negative 2, negative 9.